Protection comes high, sky high. Today, we must be on guard in the sky when it comes to protecting our resources. The national resources that are so precious to us. The offensive weapons of tomorrow are here today. Supersonic, super destructive, seemingly unresistible. To protect the future of America, the defense techniques of tomorrow had to be discovered now. They were discovered in electronics. That is how SAGE and bursting computers into military service. Electronics for combat use means new concepts, new tools, new weapons. You are listening to the heartbeat of the SAGE computer. Every instrument in this room is constantly monitoring, testing, pulse taking, controlling. For this is the programming and operations center for the SAGE computer which surrounds it. To it come continuous streams of data, which it continuously absorbs and stores on magnetic drums, tapes, and cores. Data from radar units, Texas towers, picket ships, early warning aircraft, ground observer corps, weather bureaus. To say nothing of up-to-the-minute data on all regularly scheduled commercial air flights. It also packs away information as to the number, location, and characteristics of all military craft, all anti-aircraft guns, all defensive missiles in the area. And this computer is on the job around the clock with 24-hour-a-day reliability. It is really two computers, but only one is operating the system. The other, with the same vast memory, performs as a slave, checking calculations and results, ready to take over in a matter of seconds should the master computer falter. All this is housed in one of the new headquarters of computer defense, one of the direction centers of what the Air Force calls SAGE. Beyond a fantastic capacity for calculation and memory, SAGE possesses the newest and most revolutionary advance in data processing, the display scope, a computer-generated visual display, on call as needed. Until SAGE, the miracle of the computer was its ability to calculate in split seconds and then provide printed information. But SAGE needed more than this. For the lightning shifts of air battle, the Air Force requested from IBM a computer capable of translating volumes of changing data into a continuous flow of interpretations which could be understood at a glance. Air defense required split-second presentation as well as split-second calculation. Given this objective, IBM applied the latest extension of data processing, the display scope, a giant picture tube on which computer results are instantaneously and continuously translated into graphic images. In SAGE, airmen have the battle visualized for them on the computer-generated display. 2 floors above the great computers are the batteries of display scopes. Although they look like the offspring of a marriage between a television tube and a radar screen, display scopes do not show physical images transmitted from elsewhere. They display the results of the computer's findings. SAGE, with its display scope, also has one feature possessed by neither a television or radar screen. It has memory. In case of enemy air attack, not only can a clear picture of the changing air situation be displayed on the scope, but if the airman wishes to see how things got that way, the scope can recall any previous phase of the situation from the computer's memory. By analyzing the past, SAGE can project into the future. The computer can furnish information on the countermeasures available so that the officer in charge can make his choice as to when and where to fight. Once he has selected a plan of counterattack, the computer guides interceptors and missiles to the enemy. After encounter, the computer guides the interceptors back to their bases. Aladdin's lamp couldn't do more. What is the most precious commodity that electronics defense wins us? Time. Long before the bomber reaches our defense perimeter, the computer's memory will identify it as friendly. But if a flight of planes were identified as hostile, then in a matter of minutes, time is everything. This is electronic defense in depth. And what better reason for an effective air defense? But is this protection enough? Here is protection too. The protection which comes with the possession of weapons of retaliation. Just as our defensive powers had been advancing, so have our instruments of attack. The demands of plane warfare require the fantastic ability of modern computers. The question was, how could the electronic computer be made airborne? Problems of consequence when designing a computer for ground installation became overwhelming when it was proposed to redesign them to fit into jet bombers. First, the problem of space and weight. The interior of a modern bomber is cramped for space as is. How can a bulky computer be fitted into it? For every extra pound of dead weight carried, a bomber must add many more gallons of fuel. Second, the problem of reliability. Could a computer be designed to withstand all the stresses of flight? Weather, climate, turbulence. Third, maintenance. Could a computer be designed for easy ground and air maintenance? These and other problems were all finally solved by unique design and by employing the basic principle of modular construction. The same multiple arrangement principle which was applied in the design of this doll furniture enabled the Air Force to procure an airborne computer. By designing an electronic assembly packaged in self-contained units which are then joined, a computer of flexible construction was achieved. It can either be installed in a compact unit or parts can be distributed according to the space available. Self-contained units make it easier to achieve durable construction and easier to test each unit for reliability. Under all conditions, an airborne computer is likely to be exposed to, and some highly unlikely ones. High altitudes up to 120,000 feet. Low temperatures down to 100 degrees Fahrenheit. Below zero. High temperatures up to 200 degrees Fahrenheit. Sunlight. And rain tests. Life tests of mechanical and electronic units. Vibration tests. In this test, the question is not, will the computer work under this condition, but how long will it work? Once the continued capabilities of the airborne computer were established, there was only one other major obstacle: field maintenance. To solve this problem, IBM drew on its commercial experience. It converted its control panels to military use. In order to test a unit of an airborne computer, the technician merely selects the proper control panel. He then plugs the units into the test equipment, and the signal lights tell him whether the units are working or not. This puts testing computer units in the same class as testing light bulbs. Today, the airborne computer is no longer a theory, nor an experiment. It's a fact, tested, functioning, practical, and restricted. It has gone into production under the label BRAIN, bombing, radar, navigation equipment. A new plant is being rushed to completion in Owego, New York, to boost its output. Here is a scale model of a B-52 showing the relative locations of BRAIN equipment. The rest of the system, computers, periscope, and screen, are designed to take up a minimum of space and to give a maximum of use. Computers have taken wing.
Hey, Phil, I got some crosshair jitter in both azimuth and elevation. Would you pull the AR-5 and replace it with a spare?
Sure, Dan. Give me a minute. It'll only be a second more. Yeah, I think I got it now. Okay, the amplifier's replaced. How's the jitter?
Settle down. Yeah, it's okay now. Thanks, Phil.
And as long as we're on guard, as long as we're ready to look ahead and move ahead, the future of America is secure.